Hi folks, Chuck Black here. We are doing 52 weeks of Python. We are in week 16, and this week's lesson is about generators. Now, you may or may not have heard of generators before. For me personally, I've not had a need to use generators in my life, but somebody in a previous class that I did when I was doing beginning or a little bit of intermediate Python, they said, how can you have a class and not talk about generators? And even though I disagreed, I decided I would learn a little bit more about generators. And I actually encountered them in my own software development work with a very major financial company, and they were used in a completely, in my mind, unnecessary manner, caused us a lot of headaches and hassle. And so I'm not a huge proponent of generators, but it's good to know about them. You can see I've highlighted this here, that yield is something that's going to be important that you're going to learn about. I did want to highlight something. You may be looking over here and say, hey, wait a minute, that looks a little bit different, that code that you've got. It looks like it's structured a little bit differently, and it is. I went ahead and created a folder here. This is actually a folder, not a Python package, and meaning it just has code in it. We're not going to reference this code for anything other than running itself. And I called this intermediate, and I actually added some things that we've already talked about. Everything is an object, comprehensions I put in there. I'm doing generators today. I'm going to talk about normalizing data in the next lesson. I decided to add in tuples and sets because it's good to know about them. You could argue with me that those are more basic than intermediate, but I just put them there because they fit better. So that's what we'll be talking about in the future. Today, though, the lesson is on generators. I do want to give you this get out of jail free card if you're a brand new person. Generators are probably not something that you need to know right from the get-go. In fact, I can say almost for certain they're not, unless somebody's done something mean and begun to use them. Maybe when they shouldn't. I don't know. Maybe I should be easier on generators. But if you are new and you want to just barely listen to this, I give you complete permission to do so. Try to follow along. If you do get confused, because it can be confusing at points, then you have my permission to just say, you know what, this is for the birds. I'm going to go to the next lesson, whatever you choose to do. If you're intermediate or advanced, then you probably want to know about generators because you'll probably bump into people who are using them either legitimately or maybe just because they like to use new technology, which unfortunately is a characteristic of software developers around the world that I don't necessarily agree with. Technology just for technology's sake is not always the best idea, but you'll be now exposed to what generators are and how they work. So good luck, and let's go forward with the lesson. Okay, so this lesson is about generators, and you may have never even heard of generators. Even if you're just new to software, you've probably heard of looping, you've heard of data structure, things like arrays or lists or dictionaries, maps, etc. You've heard of that type of stuff. Of course, you know about printing and strings and stuff, but you haven't heard of generators. And so why am I talking about generators? Well, a couple of things, and my apologies if I go over this a little bit in the very introduction, which you will have listened to already. I'm not sure exactly how much I'm going to put in there, but I will show you. I have reorganized things a little bit so that under basics, I have devices, functions, strings, lists and dictionaries, etc. And I've actually created a new folder. This isn't a Python package. It's just a folder that holds code. And inside it, well, and I'm calling it intermediate because this is more than just the most basic stuff. This is getting into a little bit more computer science-y, a little bit once you've gone beyond just being sort of a rank amateur when it comes to writing software. And I've put in here some of the things that we've talked about already at this point in the sequence of lessons. I've put in here everything is an object, where we talk about the fact, obviously, that everything is an object in Python, mutability, immutability, etc. I went through list comprehensions and dictionary comprehensions and combinations of those. And now we're talking about generators. And I have to tell you, in my own personal experience, and I've been writing software for networks for something like 40 years now at advanced levels, I've not been in a situation where generators were ever of interest or a necessity for me. And in fact, it's only recently that they've become more relevant, and primarily that's because of the world of data science and dealing with huge volumes of data in a manner that needs to be making it more efficient for dealing with it. And when I say efficient, I mean efficient in terms of memory utilization, not in terms of performance, and we're going to see that. So I would probably skip generators altogether, except for a couple of things. Number one, I did a class called, I think it was something like Everything You Need to Know to Become a Python Developer. And there was a complaint from a person who said, how can you say it's everything you need to know and you didn't talk about generators? And I got to admit, at that point in time, I kind of said, huh? And I had no idea why this would be high on anybody's radar. And frankly, for the stuff that we do, I'm not sure how relevant this is, but I am telling you this because of this situation. I recently worked on a project with a major financial institution whose credit cards you probably have in your own wallet, and an individual who was, I love the guy, very smart guy, obviously. He had a little bit of something that you see in software developers or programmers, which is, in my opinion, an excessive joy in using the latest technology just for the sake of the technology. So he used generators in some of the code that he developed, and it's too strong to say it caused no end of pain for us, but it caused us a bit of pain. And so in case you run into something like this, I want you to be aware of it. So I've created this thing called generators. And what is generators? Well, here you can see I have some code under generators, and I just want to point this out. I'm going to list this side by side, split that to the right, and let you look at this code here. If you look at the code here, and you look at the code over here, you'll see, wow, those look pretty much the same. In fact, you know what? At first glance, you may say, whoops, hang on a second. If you're really sharp, you'll say, that's exactly the same. And you'll be saying, Chuck, you're a complete moron, and I agree totally. I'm looking at exactly the same code here because I did a split. I forgot to delete this one. So let's go back to this again and try to hide my embarrassment. This code right here looks suspiciously the same as this code over here. Now the difference that you may see is we have some print statements over here, which we wouldn't be able to do over there. We're doing create devices. This is the main thing that's going to be different. And over here we're doing create devices gen. But in both of these, I have something that looks like this, while true, and I get an IP address, and I come through and I say for device in devices. In my generator program that we are looking at, I have a while true loop. I gather an IP address for input, and I have a for loop that looks exactly the same. I say for device in devices gen. So in this situation, I have devices, which I did a create devices up here. You can see over here I'm using devices gen. Devices gen, I did create devices gen. So that's the difference. Okay, so let's look at create devices gen. I'm going to get rid of this and we'll return to here. And so this is what this code is doing. I'm going to do my control B. That takes me directly to create utils, where I created this function called create devices gen. Now, before we look too much into that, what happens at the end or when we exit functions quite often? What do you see? I'm giving you a clue. You have a blank statement. If I was giving you a test, I would have a blank underline, and you would be filling it in with the word a return statement. So in this situation, I'm returning the entire network when I say create network. And here when I say create devices, I'm returning all the devices I created. And in this one, create device, I am returning the device, okay? So the more relevant would be returning a list of devices here, or this network, which happens to be a nested data structure here. Now what am I doing? I have to create devices gen. The analogous function is create devices right here. Create devices, I create the list of devices. At the very end, I do a return. Do you see that? This is, I call create devices. It goes through the for loop, and it creates all of the devices, and then at the very end, it returns all of the devices that have been created. Let's look down here at create devices gen. In fact, why don't I do this? Here's something that I can do that makes it a little bit easier to look at. I want to split this. Hang on a second. I want to split this to the right. And now I'm looking at the same file, but in this situation, I want to be looking at the same file. Over here, I'm going to be looking at create devices gen. Over here, I'm going to be looking at create devices. So let's see if we can make this so that you can kind of see what's going on. Here, create devices, when I'm creating it, I'm creating a list. I'm not doing that over here in create devices gen. That gives you a clue that I'm not going to be returning a list of devices. This looks exactly the same. I'm checking to make sure that the number of devices and the number of subnets is correct. I print out this thing, beginning device creation. I haven't changed that. And so now what I end up doing is I have two nested for loops. So I have, actually, I guess this would be one nested for loop, because I have a for loop, and inside that is another for loop. And the same thing over here. For loop, for loop. Now what happens after I've done create device in my create device utils? I append it to my list. Do you see that? I created a list. I'm doing an append. At the very end, I'm doing return devices. But now, here is something weird. And I'm going to pause and tell you, if you're a new developer and you're just hanging on by a thread to everything that we've been talking about, this maybe blow your mind is a little bit too strong a word, but this is very different behavior. Normally, we are just doing return network, we're doing return created devices, we're doing return device, we're doing return statements, and we are done. When you have a generator, when you return something that is a generator, what is ending up happening is you are pausing your execution in the middle of what you are doing, and you are returning with your current state, data that reflects your current state. Let me explain how that actually works. So this is the kind of normal way. This is, I suspect, what you'll be doing most of the time in your life. But if you choose to do generators, you'll know you're using a generator because of the fact that you'll see a yield statement. Yield is the statement that we use. And if you want to understand the English of that, basically it says yield kind of means stop in a certain sense. In traffic, entryways into a motorway or something, it says yield to traffic. That means stop to allow other traffic. So this is basically saying, I want you to stop in the middle, and I want you to return where we are at this particular point in time. Okay, so for those of you that are intermediate or advanced, you're probably going to be able to pick up on this. If you are new, just hang in there. I give you my permission, if you are new, to say, you know what, that's not something I really care about. Now at least you know what to look at when you see a function that has a yield statement in it. That means that it's going to be returning what we call a generator. And now is when it gets kind of weird, because what's going to happen is basically that function is going to return immediately. It's not going to go through the process of creating everything. It's going to get to a particular spot and it's going to return this generator. And so just get that in your mind. In this other situation, we went through all of the device creation and then we did a return of the entire list. This time we're not doing that. We are basically returning the generator. And here's what's going to happen. When I have a generator, what I can do is I can treat it as if it was the entire list in the syntax of my for statement. But what's going to happen is every time I go through an iteration of this, it's going to return to this function and it's going to do the next iteration. That's the easiest way that I can describe this. So the first time through, it's going to give me the very first device. The second time through, it's going to give me the second device. The third time through, it's going to give me the third device, etc. So when I go through this, I'm basically getting my devices one at a time, just like I am in that other code that we looked at, the list versus dictionaries. I'm going through it one device at a time, but the difference is that device is getting generated one device at a time because I'm using the generator. So let's take a step back and think about why we would do this. So why would you use a generator rather than using the regular function that returns a list as we have done before? Well, if you imagine a world of, say, data science, where you have huge volumes of data, let's say you have 100 million items of data that you are going to process and do something with. If you go and request that data and it returns to you 100 million of these items, if those items are of any significant size, then number one, it may take extremely long for you to get that data back. And number two, it may blow away your application because it will take up too much memory. And so it's significantly because of memory usage that you would use a generator. What we're going to see when I begin to execute this, as we're going to see that not only is it slower, but it introduces problems. And you may be looking at this example and saying, only a moron would be using a generator for what you're demonstrating here. And I would say, first of all, I agree totally, and I would confess to being a moron at least part of the time. But one of the legitimate reasons that I'm doing this is because I want to show you some of the dangers involved with using something like a generator and also some of the trade-offs. I don't have memory issues with my 64,000 devices that I'm getting returned to me when I created them. Here I create devices 254, 254. I don't have memory issues when I do that. It barely has an impact on my memory. I've looked at it using this system monitor. So I know that I would not be normally needing to do this, but I just wanted to show you what it's going to take in order to search for something, and then also how you may end up with problems that you didn't anticipate. And in order to do that, I'm going to actually run this, and then we will see what I'm talking about. Now, I'm running this generator's program. Let me move this over to the top. So let's see, right top. So here it is. I've created all of my IP addresses. I'm not listing them all, but they were, I'm hoping I remember this right, 10.0.x.x. So I'm going to say 10.0.1.1. And I'm going to let it find this, and it's going to find it, just so you know, it's going to find it both searching using the generator, and then it's going to find it using a dictionary, and it's going to compare the times. Now, I think before it was like 3 seconds when you had a list versus a dictionary when I'm finding the very first one. Let's see what it is with this generator. Okay, let me make this a little bit easier to see. So it says dictionary search was 8 times faster than a generator search. If I was to go then and find 10.0.254.254, I believe that's going to be the last one. I'm going to hit return here, and it's going to go and find it. And if you recall from lists versus dictionaries, it was 3,000 times slower. It fluctuated between like 28 and 3,800 times slower. This is actually like 20 times worse than that. This is 60,000 times slower to do a generator search. So it took a very long time. You can see the difference in this doing it through the generator versus this using a dictionary. Dictionary, it's always going to be about the same amount of time. So you can just get a little bit of an idea of what's going on. Now, by the way, I just want to point this out. This value here, remember when we did lists versus dictionaries, these two values were identical. They're not identical here because we've generated them entirely separately. Remember when we did lists versus dictionaries, we created the entire list of items, and then we had dictionary that pointed at those items. When we did a create devices, we actually had a dictionary, and the dictionary pointed at exactly the same thing. So these IDs would be the same. We're not doing that here. The IDs are actually different. So that's neither here nor there. But I just did want to point that out to you in case you looked at that as I did just this moment and said, wait a minute, those aren't the same. And it's true that they aren't the same. They're not supposed to be the same because we're doing it through a generator. And actually what you will find, let's look a little bit further. I'm noticing more flaws in what I've done. You'll have to trust me that what I'm finding is the IP address, but remember the generator is doing something entirely different. We're not pointing at the same data. That's why the name and the vendor and the OS, etc. are going to be different. But you'll notice the important thing is, what were we searching for? The IP address. Is the IP address identical between those two? Yes, it is. So this is giving you an idea of what's going on. And let's talk about that for a second. What actually is going on? So every time, let me go back here. When I am searching for this item using a generator, the first time through, what's going to happen is this function is going to get called, and I'm going to do the first iteration, and it's going to yield to me the first device that it creates. All right? And it's going to return that, and it's going to remember where it was. Okay, are you with me? It's going to be in this for loop. It saves its state. I'm not going to go into the details of how exactly it does that. That's an interesting thing if you're a computer science person. If you're not, it's going to just confuse you. So just remember, it's remembering where in this for loop it was. The second time through, when I go through and I try to find it the second time, so I'm going through, where is it? Sorry, when I'm going through this for loop the second time and it's trying to find it, it's going to call back into this, this function where we got the device's generator from, and it's going to do the next iteration. And I'm going to keep going back to here, going to the next one, which will cause me to come here and do the next one, yield the next one, yield the next one, yield the next one. And you notice for this one, it's going to have to go through all 254.254 of them before it gives me the final answer back. And it will finally find it. And that's why it took 60,000 times more. Okay? So basically, what happens is when I do a for loop with a generator, it's actually not iterating through a list. It's going physically back into that function and it's iterating the next iteration in this loop. That's how you can think it. And every time through, it yields one device, then it yields the next device and the next device, etc. Okay, that's exactly what it is doing, and that is why it is actually taking so long. But here's the important thing. Remember, it's retaining its state. This device's gen is retaining its state. So let me show you something. Now I'm going to come back and I say I want you to find 10.0.1.254, let's say. Let's find that one. It will be the 254th device. Let's see what the answer to this is. What? It tells me the IP address is not found. How can that be? I can run the list versus dictionaries and I can bounce around everywhere in my list of these devices and I can find anyone. What's going on? Is there a bug in the program? And the answer is there's not a bug in the program. The situation is this: devices gen, remember? That was returned to us. This generator was returned to us. And what has happened? And for those of you that are new, you may not be getting this. For those of you that have been around the block a couple of times, stick with me and I think that you'll understand this. I've not actually described this to people in a class before, so I'm hoping that this description is going to be useful. Remember, I said it remembers its state. This generator remembers its state. So every time I come in here, when I call that generator, it's not starting at the top. It's actually resuming where it was. Where was it? It was in this for loop. It's going through this for loop. Okay, every time I re-enter this code using the generator, every time I do this for and I reference this generator, when it comes in here, it resumes in this for loop exactly where it was. So it's going 1.1, 1.2, 1.3, 1.4, etc. And eventually, for the one that we did, that was 254.254, it got to 254.254 and it found it. That's good. And then it returned that value. Okay? But here's the problem. Remember, it remembers its state in this for loop. Where is it in this for loop? It's at the very end of this for loop. It's at 254.254 because that's what we created when we created the generator. It's at 254.254. It remembers its state. So every time I come back in here, it's at the end. All right? That's why it won't find it. I could type in anything I want here, 10.0.1.1, and it's not going to find it. I actually don't know the answer to this, but I think it won't find it if I do 254.254, the one that I found before. It should have gone past this already. It didn't find it again. So let's do this. Let's kill this and let's start over. And let's run this program again. So now I'm going to type in 10.0.1.1 and it finds it. And now I'm going to do 10.0.1.2 and it found it. Now I'm going to do 10.0.100.100. It took it a while, but it found it. Now I'm going to do 10.0.100.101. And it found it. Remember, notice how fast it found it. Look at the difference here. I'm going to pause and I'm going to ask you, why did it take 37,000 times longer to find 100.100 and it only took 6 times longer to find 100.101? You can pause it right now if you want to think about it for a while. I will tell you why. It is because, remember, it remembers its state. So what was its state? It was at the subnet index was 100 and the device index was 100 when it returned this one up here. Then when I asked for 100.101, this was at 100. Let's see, where am I? This was at 100. This one here was just the very next one was going to be 101, so it found it immediately. Okay? So now the next one I'm going to do, this one's going to fail. I'm going to do 10.0.100.100. We just found that. In fact, just for fun, yeah, I'll leave it at 100. All right? Remember, we've gone past 100. So what is it going to say? I'm assuming, and I haven't actually tested this particular one, I'm assuming it will say not found, IP address not found. So it says IP address not found, try again. Now I might say, oh, I see. I went back one. So why don't I do something different? Why don't I go forward? 10.0.200.100 or whatever. Surely it will be able to find this one. And it won't find it. Why is that? That's because this loop right here, remember it retained its state. When I asked it to find 100.100, what happened? It iterated all the way to the end. It is at the very, very end of both of these for loops, of the nested for loops. Nothing I can type in will it find. Okay? Even though I went forward. When I said 100.100 and it didn't find it, it exhausted everything in here. That is why I say this is a stupid way to use a generator. But I wanted to point two things out to you. Hopefully you've understood this aspect of it, okay? The two things I wanted to point out. Number one, it takes way longer when you're doing a generator to find things than it does in a list, okay? So remember that. That's a lot longer. And the second thing to remember is it maintains its state. If you go back and you attempt to change, if you attempt to find something that it has already iterated through, so you change what you're searching for, you try to get at something that is earlier in the list, you're not going to be able to do that because it's made to iterate sequentially through the list, and it'll do that one time and one time alone. You need to reset it if you're not actually if you want to go back over items in your list or lists that you've already exhausted. Okay, so hopefully this silly example gives you an idea of some of the things to be aware of. There are other things. There's something that a buddy of mine that works at TLAC that I worked with for a while, who worked at Google for many years. We both bumped into getting bitten in the butt by this individual who used a yield statement that made it very, very difficult for us to do unit testing because of this very fact. So just a word to the wise. Now what I'll talk about next is we'll go through a couple other examples of how you might use generators in using comprehensions. Okay, so let's finish up our discussion of generators with a couple of relatively simple examples. So we're starting right here. This is a simple generator comprehension. So look at this. This is a string. This is stuff that I've used in examples before. It represents a device separated with different items separated by commas. Here's the device name, the vendor, the model. I can't remember if I call it what did I call it? The model, the OS, and then extra stupid stuff. I left that in there for some reason. Not sure why. But the point is, what we're going to do first is what you've seen us do before. Remember list comprehensions? When you see square brackets on the right-hand side of an equal sign, that's an indication that what's coming at us is going to be a list. Okay, so this is going to be a list, and when we look inside this list, we see this type of syntax where we have a for loop in the middle. And remember, that's an indication to us that it is a list comprehension, and so we start from the inside and work our way out. For item in device string, that's this thing right here, dot split. Now, when you take a string and you do a split, we've done this before in our section on strings, what do you end up with? It's going to split it based on a comma, and the end result is what? The end result is going to be a list, and this will be the first item in the list, this will be the second item in the list, this will be the third item in the list, etc. So we end up with a list of these things. And then what we're doing here is we are taking that particular item in the list. For every item, we're going to strip it, meaning we're going to get rid of the leading and ending blanks. So for something like iOS here, there's a leading and an ending blank, and same for the extra stupid stuff. And then I print it out, and when I print it, this is just my print statement. It prints out this handy, you can see that it's a list because of the square brackets, and these are all of the items that have been neatly trimmed off. Now, look here. Here's my next line of doing something. It looks exactly the same as the one above, doesn't it? But wait a minute, there's something different here. What's this? There are round brackets. In the US, we call these parentheses. I'll call them round brackets just for more common language. These round brackets are not present there. What does that mean? Well, this is the syntax that Python uses to denote a generator. Now look up here. What did this return when you do a split? What does it return? It returns a word that starts with L. That's right. It returns a list of the items from device string. This would normally return a list, but because it's surrounded by these parentheses, these round brackets, it's going to return a generator. You got it. It's going to return a generator. So basically, it's going to do what we did here, where we had this generator that went through a loop and it did a yield after every one. It's going to effectively do the same thing. Now it happens all within this one line. This is my for loop that does it. And what we're going to do is for every item that it returns to us, we're going to do a strip and put it into the list. And as you can see, the end result is exactly the same. In this situation, this was a list, and we iterated through the list with the for statement. In this situation, this is a generator, and we iterate through the items in the generator. Okay? Now, these are simple situations that, there's no real need for us to use a generator. If I had 10 million of these things, then, and I was memory constrained, or that was an issue, then I might want to use a generator in that situation. Now let's look at another situation, and this one breaks it out a little bit just in order to print it. So let's look here. This is, I say it's a more interesting generator comprehension. This one seems pretty interesting to me. I'm not sure why I called this more interesting, but maybe this is broken up. It makes it a little bit more interesting. Here I have something that looks like a list comprehension, but it's using these round brackets, so I know it is a generator comprehension. So what is it doing? Well, let's start from the inside and work our way out. Here is a for loop, and I'm going for I in range 1 to 25. That means I'm going to iterate with I being first the value 1, second the value 2, third the value 3, etc. That's my for loop. I'm going to iterate through these things. And for every iteration, what am I going to do? I'm going to return create device. Well, create device, that's the thing that's here in create utils. This is the Same thing that I'm doing right here, create device. So I'm calling this function where I'm randomly generating a device. So I'm going to call create device, but because I've made this a generator comprehension, this for loop is not going to return a list of these things in the range, but rather it is going to, one at a time, go through this, and we are going to, the result is going to be a generator rather than a list of these devices. I didn't explain that very well. Let me try to explain that again. The result of this, rather than being a list, which is what you would expect when you go through this, is going to be a generator. And so it's actually not doing anything until I begin to use devices gen. So it's like this is a function that is going to get called, and it's going to remember its state. I'm asking you to remember that it will remember the state that it's in when it goes through this for loop. So the first time through here, it's going to call create device on 1, 1, and then it's going to print it. And then the second time through this for loop, it's going to call devices gen, which is this generator, with it will have the value of 2, 1, and it will generate the device, and then I'm going to print it out. And if I look down here, you're going to be able to see here are my generated devices from this generator. 10.0.1.1, 10.0.1.2, etc., all the way up to 25, up to 24, not inclusive. So we went from 1 to 25. So we created 24 of those devices, but we did it one at a time using the generator because I'm using a generator comprehension. Remember, just to make this clear, what this returns, it doesn't execute this for loop because this is a generator comprehension. It saves the generation of all of these iterations until you reference it here, and then it does it one at a time, remembering its state until it's all the way done. Okay? So hopefully that makes some sense. Like I say, I don't tend to use generators in my normal software life. It's something that we use for large sets of data. Hopefully these comprehensions haven't been too incomprehensible, but they shed a little bit light, hopefully, on what you get when you use generator comprehensions. Okay, so let's review what we talked about to try to hopefully solidify in your mind what these generators are all about. Now, if you see a function that has a yield statement in it, that means that this function is returning a generator. And the idea of a generator is that it's going to remember its state and it's going to be re-entered every time the generator is referenced, and it's going to maintain its state. And in this situation, it's basically iterating through creation of all of these devices. The way that you use a generator is you call the function that returns a generator. That's what we did there. And then you use it just as if you would be using a list, but the difference is it is actually going to re-enter that code every time at this location, and it's going to continue to yield another device, another device, another device every time I go through this for loop. So it goes through it one at a time, and the reason that you use a generator is to cut down on memory usage, important in fields like data science and the like, where you have huge volumes of data and you are not required to have random access to various points of data. Here I tried to find stuff. We showed how slow that was. So you don't want to do it if you're trying to find stuff unless you have memory issues. That's how you use a generator. And then we talked a little bit about this generator comprehension. Before I did this, I didn't even know they existed, so I had to learn about them myself. Here's an example of a generator comprehension. Instead of returning a list like this does, it returns a generator. And so every time we go through this, it's going to actually invoke, re-enter this generator and call the next one, which in this situation is just the split. And then here's a situation where we broke it out a little bit, where we did create device similar to what we did in create utils that you looked at. And I did it for the range of 1 to 25, called create device. Really, this didn't get called right at this point where this line gets executed. Devices gen is not a list. It doesn't have anything in it. It is something that is callable, and that callable thing is called a generator. And so the first time through in this for loop, it does the first one. The second time through in the for loop, it does the second one, etc. That's how generators work. Now you know a little bit about generators, whether you use them or not. I have no idea, but knowledge is always a good thing. So hopefully you have enough filled up in your brain about generators that you can have at least some understanding. And if you do encounter them, and the way that you'll know that you're encountering one is by this yield statement, then you will know what it's all about and what it's trying to do. Good luck with generators in your Python life.